Here we're going to prove that the number n is an odd integer if and only if 3n plus 5 is equal to 6k plus 8 for some integer k. We have an if and only if statement, and so we need to prove both directions of that. I'll start with the only if, which is the arrow pointing in that direction. So here we're going to show that if n is an odd integer, then this expression holds for some integer k. So we'll start by supposing that n is an odd integer. Then there exists an integer. We're already using k, so let's maybe say m. We already have n there. Let me use r and s. If I need any of those, we'll just say there exists an integer r. I don't need s yet. Such that n is equal to 2 times r plus 1. Then we're going to take that and substitute it in to our equation over here. And we'll start with the 3n plus 5. We're trying to end up with 6 times an integer plus 8. So 3n plus 5 is equal to 3 times 2r plus 1 plus 5. So just replacing n with what it's equal to from our definition of odd. Then I'm going to distribute the 3 through. So we get 6r plus 3 plus 5, which is equal to 6r plus 8, and that fits the form directly. I don't have to do any additional factoring. Thus, since r is an integer, 3n plus 5 is equal to 6 times, now maybe I should have used k and it would have worked out nicely, but 6k plus 8 for some integer k. And here r is equal to k. If I had had to do some additional manipulating, then I may have had 6 times something else, some other expression involving r that didn't work out as cleanly. But here it did work out nicely, so we'll go ahead and use the variable name that was mentioned above. So that completes that direction of the proof. If you want to go ahead and put an end of proof symbol there, you could, although with the if and only if statements, you definitely need some summarizing statement at the end, so I'll hold off until then. For the if direction, that's the arrow coming back in the other way, we're going to start with supposing that 3n plus 5 is equal to 6k plus 8 for some integer k. And then we want to show that we can write n as 2 times an integer plus 1. So we're going to take that expression and start manipulating it. I'm first going to subtract 5 from both sides, and we're going to end up with 6k plus 3. And then dividing both sides by 3 or multiplying through by 1/3 gives us n equals 2 times k plus 1, which is exactly the form that we want. K is an integer, so thus n is odd. Don't really need to restate that k is an integer down here since we just wrote it in the first sentence there. And in the previous part of the proof, I maybe didn't need to restate that r was an integer. We had it up there. We could have maybe gone right into that conclusion. So, overall conclusion, therefore, just going to restate what we said up here. N is odd if and only if 3n plus 5 is equal to 6k plus 8. And I'll be a bit more concise here. For some, and we'll just use the shorthand for some k in z. And that completes the proof in both directions for that if and only if statement.